Now, in problem number 8, they tell us that we want to find one last problem. For problem 8, we're looking at the probability or area of something being less than 0. So we can still do the same idea. We can draw our standard normal curve, but we do know 0 goes exactly in the middle. So if we want all the area to the left, yes, you can use your calculator and use the negative 10 to the 99th for the left-hand side for your very start value. Or you can remember all the area has to add up to 1. So if I'm smack dab in the middle, half of the area to the left is just an even 0.5. So my area to the left is just going to be 0.5. Or, like I said, you can still do a normal CDF, except for on the left-hand side, what you would use is a negative. You have a negative infinity because you're going off forever, so you'd use a negative 10 to the 99th as your first value because you technically don't have a starting value, comma, and you'd go up all the way to where you stop in the middle at 0. And what you would get is 0.5. You'll get the same exact value as just figuring it out, kind of by working it out with just thought process. I will say you can do a lot of these problems there is a normal distribution table that you can use, and I believe it's table A2. But your calculator is using the table when you do this normal CDF and taking care of everything for you. And then you don't have to worry about dragging around the table. However, if you do get used to using the tables, that's absolutely fine. But then you need to print out the tables before you take your test so that you have something with you when you go to take your test. So just be careful about that. So what we want to get used to in this chapter, in chapter 6, is that whether we are asked for areas, probabilities, or basically percentages, they all mean the same thing. We're all going to be drawing a curve and figuring out either what's to the left, to the right, or in between two values. And we'll be using this curve, this standard normal curve with z's on the bottoms most times, or zeros in the middle. So this is kind of the picture we really want to get used to. Continuing along, we want to do a little bit more with these. In this next problem, in problem number 1, look, we've got a P for probability. So we're going to draw our normal distribution because we also see a Z. So that means we've got a normal curve. Then the value we want to stick on our normal curve is this 0.45. That's the Z value we care about, which is a little bit bigger than 1. The question is, do I want the area to the left or the area to the right? Well, the fact that they gave me a less than tells me exactly what I want. I want an area to the left. Because less than, Z values that are less than 0.45 are all to the left. So this is what I want to find. So even though they asked me for a probability, we're still going to do what we've done the same time, which is find the area. Because again, areas and probabilities mean the same thing. Just like before, if we're going to the left forever, instead of using negative infinity, we're going to use a negative 10 to the 99th. So we'll use a negative 10 to the 99th. So we'll have our normal CDF, just like before. That starts out with a negative 10 to the 99th on the left, comma, and then my graph or area is going to stop at a Z value of 0.45. And we'll have our calculator go ahead and calculate this area for us, or our probability for us, which is a 0.6736. And that's our final answer. Now, let's move along to problem number 2. In problem number 2, again, we have z-values, so we'll draw our standard normal curve. This time I have two different values. I've got a left side of negative 2.05 and a right side of 2.05. And notice on the positive 2.05, it says we want to be less than, which means to the left. And actually, it looks funny, but this other part actually has the number first, so it should point the reverse direction, is going to also point inside. Means we want the area in between those two values. So we're still going to do a normal CDF, but this time we have a starting and a ending value. So we'll do our normal CDF just like before. But this time we'll have our negative 2.05 as our starting value, comma, our positive 2.05 as our ending value, and then we'll go ahead and stop there, and then we can use our calculator to figure out what that value is going to be. And what our calculator gives us is a 0.9596. And that's our final answer for our probability or area between a z-value of negative 2.05 and positive 2.05. Let's take a look at 3 because it's a little bit different. In 3, we again have two z-values, so we'll still have our standard normal curve. And let's see, on the first part, we have z is less than negative 1.96. So here's negative 1.96 here. And less than, though, means I want to the left. And they also have another piece. Z is greater than 1.96. So here is positive 1.96, but they said greater on this side. And then remember what the word or means. In probabilities, it means to add. So it means we want to take these two areas and add them up. Now, what's really nice is that these two areas are going to actually end up being the same. And the reason why they'll end up being the same is because, what did we say about normal curves, is that they were symmetric. Meaning whatever happens on one side happens on the other. So the only reason why these two areas will be the same is because they have the exact same z-value, except for one's negative and one's positive. If they were even slightly different, they would not be the same area on both ends. So how do we find the area on one of the two ends? Well, let's go after the pink end first. Remember that pink end is going off towards negative infinity. We can't actually use negative infinity though, so we'll use a negative 10 to the 99th like we did before. So for this left-hand side here, we'll do a normal CDF of negative 10 to the 99th. And we'll stop it at negative 1.96. And we'll see what just that end of area ends up being. And what you end up getting is a 0.025. Now, had you decided to do the same thing for the right-hand side, you could. You just don't have a right end. You'd use your positive infinity. So instead of that, you'd do 10 to the 99th. You'd do another normal CDF of, this time starting at a positive 1.96 and going up to positive 10 to the 99th, and you'd get the same value of 0.025. But remember, this was a case of or. So I need to take these two pieces and either take one of them and multiply them by 2, or take them separately, add them up, and because they're the same, it will end up being 0.05 is your probability. So the only time you have to really worry about doing a little bit of math is if you have two ends. Then you have to find each and add them up if they're different. If they're the same, you can just find one and multiply it by 2. Last one, let's take a look at problem 4. In problem 4, we can again do a normal curve because we see the z there. And let's see, what z value did they give us? They give us a negative, which is a little bit on the left, negative 0.27. And they also tell us they want it to be, let's see, greater than. Well, greater than means they want the area to the right. So, just like the ones before, if we are going to go off all the way to the right, that means we've got an infinity here. There's no way to tell our calculator infinity, so we'll just use a really big positive value of 10 to the 99th. So we'll do our normal CDF one last time. And just like before, it starts at a negative 0.27 and comma ends at, we're going to say 10 to the 99th because we can't say infinity. And then we'll close that off and have our calculator figure out what that value is for us. So that gives us a 0.6064 as our probability or area to the right there.